Good morning, Cristo Rey Saints. Happy Monday. Statistics class. This is your weekly video introduction and overview of the topic we'll be covering this week. Actually, this week and the first part of next week. As you know, spring break begins on next Thursday. So we're all looking forward to actually being home but not having to do homework. I know I am, so hope you guys are looking forward to that too. In the meantime, we have this week and then the first part of next week to continue with class. So I have posted in Google Classroom the schedule for this week and next. So please take a look at that Google document. It has the same format as the first 2 weeks with details in there about what the assignments are coming up. You'll also notice in Google Classroom that I have posted all the assignments, including the Khan Academy deadlines and the readings and problems I want you to look at before this Thursday's class. You will have your regular Zoom class this Thursday at 9 a.m. So this first 2 weeks, we've kind of been getting the hang of things. By now, you guys know the drill. So I expect to see everyone on Thursday at 9 a.m. If for some reason you run into trouble, then I would like a message from you after that to let me know why you weren't able to make it to that Zoom conference on this Thursday at 9 a.m. Okay, so this week's topic continues in that same chapter in the book, chapter 12. We're talking this week about combinations. So last week it was permutations, this week combinations, and this can be a confusing concept. So I want to make sure that we take the time on it and that you are able to ask the questions that you need to ask. So make sure you're doing that, thinking through the questions you want to ask before we come to class on Thursday, and then you can send me questions, post them in the Google Classroom as well, if you like. Okay, so let's switch over to Elmo, and I'm just going to take some notes. I will post these in Google Classroom later, not today. If not today, then by tomorrow. So what we're going to be discussing today are combinations. So in the book, this is on page 297. So if you have your book available, probably be good for you to have it open to page 297 as well. So let me just show you what I'm talking about. Okay, on page 297, this is talking about step 2. Step 1 was permutations. Step 2 is combinations. So what is a combination? And how does it differ from a permutation? Because those can be hard to figure out sometimes. Okay, so a combination is choosing objects from a group of different objects where I don't care about the order in which they are chosen. Okay, so the key phrase here is I don't care about the order. Okay, so that's what makes a combination different from a permutation, is that the order doesn't matter. So I could pick 3 people out of a group of 10, and I'm not concerned about who's first, second, or third. I just want to know how many different groups could I pick out of that group of 10. So once I choose someone and they're in the group, it doesn't matter whether they were chosen first, second, or third. Okay. So for example, if I'm choosing a small group or team of people, let's say there are 10 math students in the Mathlete squad and I want to choose 5 for the upcoming meet. How many different teams could I create? Notice the key word here is teams. The team is the group I'm choosing. The group of 5 I'm choosing out of those 10. Why is this not a permutation problem? It's not a permutation problem because it doesn't matter the order I pick them in. Okay? It doesn't matter the order I pick them in. I just want to know how many different groups of 5 can I pick out of that group of 10 students. Okay, so on page 297, this is the formula. So we had a similar formula for permutations. You can look back and see how that differs on page 296 or 295. Okay, so we're going to use a C here instead of a P, but it still has these same symbols, N and R. And the symbols mean the same thing. N means the number of objects I'm choosing from, different, unique objects. R is the number I'm choosing. So I'm choosing R objects out of N that are available. And so here's my formula. It's N factorial, remember what the factorial means, divided by R factorial times N minus R factorial. So what's the new part here? The new part here is this, compared to the permutation formula. If you look back at the permutation formula, it's only this, N factorial divided by N minus R factorial. In the combinations, I have to also divide by r factorial. R is the number of items I'm choosing, small group, out of the larger group of n things. This is on page 297. So for this particular problem here, I have a group of 10 students I'm choosing from, and I want to choose groups of 5. Okay, then the problem is going to be this. It's going to be a combination because I don't care about the order I picked them in. Okay, I just want the different arrangements that I can have of those 5 people. Here I'm going to put 10 because that's how many I'm choosing from, and I'm choosing 5 out of the 10. Okay, so how does that work again? Well, that's going to be 10 factorial divided by r is 5, that's 5 factorial divided by 10 minus 5 factorial. Okay, so we're going to simplify this a little bit. We get 10 factorial divided by 5 factorial, and then 10 minus 5 is also 5 factorial. Okay, so that's how we apply the formula, and then we want to simplify this down because we want to know, right, how many. We want to know the number, not just the symbols. Okay, so what is 10 factorial again? Well, recall from last week, when we multiply this out, this is what we're looking at. And we're not going to actually multiply that out because we already know that some things are going to cancel, right? And as it happens with this problem, there's the same thing repeated. I have 5 factorial times 5 factorial, so that means this. Okay, so I know, just like with permutations, right, a big section of this is just going to cancel out because all those things are the same. Okay, but now I have 10 times 9 times 8 times 7 times 6 is still here in the numerator, and in the denominator I still have 5 times 4 times 3 times 2 times 1. So question is, what does this actually work out to be? Well, this is where it's just canceling factors that are the same. So, right, the 1 I really don't even have to worry about, but notice I have a 4 times 2, and that's the same as 8. So I can cancel out the 4 and the 2 here with the 8 there. Okay, also 5 goes into 10 2 times, and 3 goes into 9 3 times. Also goes into 6, by the way. Okay, so what do I have left? Let's circle what I have left. I've got a 2 there, I've got a 3 there, the 8 canceled out, I have a 7, and I have a 6. And everything else has canceled out down here to 1s. This is canceled out to 1s. So my answer is 2 times 3 times 7 times 6. Okay, so calculator if you need it. So this is 6 times 6 is 36 times 7. So we can bring it down into a smaller number of numbers to multiply if you don't have a calculator handy. Right, just rearrange them, put them in the order that will help you figure out the answer. When you're multiplying, you can do them in any order. Okay, so 36 times 7, 6 times 7 is 42. Okay, so you can check that answer. And the answer is 252. So if I have 10 students and I'm just choosing groups of 5, there are 252 different groups of 5 that I could choose. Okay, each of those 10 people is unique, right? So once I choose that person for a team, they're on the team, and it doesn't matter whether I chose them first or second or third or fourth or fifth. Okay, so in general, the number of combinations is going to be smaller than the number of permutations. Okay, the number of combinations is going to be smaller than the number of permutations because the permutation is the order. Okay, so right, I could choose a particular person first or second or third or fourth or fifth. That would matter if I wanted the permutations, but it doesn't matter if I want the combinations. So if that person is chosen at any point, they're going to be on the team. So that's going to reduce the number of different unique groupings I can have for a combination. Okay, so the main thing is the same. I have to determine in the problem, first I determined, does the order matter? If the order matters, I need to use permutations. If the order doesn't matter, and I'm just wanting to group the items in a group together, like this example, then it's a combination. But the formula is going to look very similar. I'm always going to have to identify how many am I choosing from, and then how many am I choosing in the smaller group, and then I just apply the formula itself. Okay, so there are examples of that in the Khan Academy videos as well as in your book. Okay, and we'll look at your exercises on your worksheet here in a second. I want to say just a couple more things about the counting principle, which I didn't focus on last week. Okay, this difference between the or and the and when I'm counting outcomes or the number of things that can happen, right? Anytime you see the or term, that means add. Anytime you see the and, that means multiply. So this is a really important thing you want to have somewhere in your notes. Okay, so for example, if I'm ordering in my favorite coffee spot, there are 4 different drinks and 5 tasty pastries available, right? I have some choices to make when I go to that spot. So here are 2 different scenarios. What are the number of options available to me if I can choose 1 drink or 1 pastry? Okay, so 1 drink or 1 pastry. So I can't have a drink and a pastry. I can have one or the other. Okay, so the number of outcomes is by adding the number of options in each category. So 4 plus 5, 9. So I have 9 choices available to me. Sorry, oops, I wrote that in the wrong place. This is what you call live video. Okay, so this should be 4 plus 5 equals 9. Okay, there are 9 options available to me in this example because I can only choose one from one group or the other group. So I add them 4 plus 5. Okay, but suppose my options are changed and I can now choose 1 drink and 1 pastry. Now, how many choices do I have available? So since this is an and, the number of options I have available is 4 times 5, which is 20. Okay, so I can choose 1 drink and 1 pastry. I have 20 different combinations, right? I could choose drink number 1 and any of the 5 pastries, and I can repeat that process for drink 2, drink 3, and drink 4. For each drink, I have 5 choices of pastry. So this is like your counting tree example we looked at last week. So there are 20 possible 20 possible choices if it's an and option, right? If it's an or option, then I only have 9 choices available to me. Okay, so and increases your number of options, right? Or decreases your number of options. It sort of makes intuitive sense to you, I think. Okay, so what should you be preparing for Thursday's class? On page 298, there are some just checking questions. So go ahead and look at those before class. Make sure you've read through the section, pages that I've highlighted as well. Let's look quickly at your worksheet because I also want you to be able to show me what you've done here. So let's do a quick example. We'll do problem number 2. These are combinations now. This is in your packet. Right, so look at number 2. I want to know the combinations, possible combinations of these 4 letters taken 2 at a time. So if we apply the formula, we know how many we're going to have. We know the number of combinations is, there are 4 items, that's n, so n equals 4. And 2 at a time, r is 2. So that means 4c2, okay? So that's 4 factorial divided by 2 factorial times 4 minus 2 factorial. So this is just applying that formula. So that's 4 times 3 times 2 times 1. And then here I have 2 times 1. And then I have 2 times 1 again. So 4 times 3, this is small enough I can multiply it out, right? That's 24. 2 times 2 is 4, so 6. So there should be 6 different combinations. Okay, and the way this shows up is I'm taking 2 at a time. So let's say I choose A and B. Okay, and then I can choose A and C. And then I can choose A and D. Okay, now I'm going to go back and I'm going to put B in the first position. Okay, I choose B first. So let's say I choose A. Well, if I was doing permutations, I would want to keep that. But notice, B and A are the same as A and B if I'm looking at combinations. So I'm not going to include that one. Okay, what about B and C? That's a new group because B and C do not appear together in a group yet. Okay, and then also B and D is also a new one. It doesn't appear here. Okay, because it's a combination, I'm looking at whether it's in the group, not which order it's in. Okay, so then I would go back here again and I would do C and A. but I already have that, so I don't need it. Okay, C and B, I already have those two in a group. I don't need that one. C and D, I don't have that yet, so I'm going to keep that one. Okay, well, there's 6. I already know that's all of them, but let's just see why the other ones wouldn't work for D, all right? Once again, if I use D and A, I already have those two in a group. Okay, D and B, I also already have those two in a group. I choose D and C, I already have those in a group. Okay, so all the ones I've crossed out would be included if it was permutations, right? But I'm doing combinations, so I don't care what order they're picked in. So now these 6, right, are the 6 combinations of those 4 letters taken 2 at a time. Okay, so that's why it's 6 in this example. Okay, so that's an example. Down below, you've got some expressions to evaluate. So for Thursday, just to be clear, I want you to have worked out all the problems on this worksheet. Okay, in Khan Academy, I believe you have 4 videos and an exercise. Those aren't actually due, right, until Sunday night or Monday night, I think. So check the due date in Google Classroom on that. But I do want you to have the worksheet finished, and I want you to have reread the section, and looked at the just checking section on page 298. Okay, so that's what's coming up this week. Combinations, and permutations. Make sure you take a look at the book one more time, read through that, try those problems, and post your questions or send me an email and let me know. I will have office hours on Wednesday as usual. Check your schedule for all those details. Okay, hope you're doing well, everyone, and look forward to seeing you on Thursday, if not before. Take care.